Hello again. Now that we know how to implement conditionals in assembly, let's see how we implement loops, which is going to involve conditionals. So here I'm showing a simple example of a while loop that keeps executing the loop body here as long as the condition holds. And in this case, if the condition is while sum is not equal to 0, it keeps executing. Okay? And when sum is no longer not equal to 0, the loop is going to stop. So the important thing to note here in our implementation of a loop in assembly is, first, there's an unconditional jump here that jumps to the beginning of the loop. And second, there's another jump here that determines when the loop is done. When this, in other words, when this condition no longer is satisfied. So when that happens, we're going to jump to the end of the loop because the loop is done. So we're going to jump past the loop. Okay? And how the compiler implements other loops should be straightforward. The only trick is where you put the conditional branch. At the top, you're going to put either at the top of the loop or at the bottom of the loop. For example, if you're to implement for I equals 0, it's going to be looping until until y is greater than 100 or equal, and it's going to keep incrementing I. So before the loop starts, we're going to set I to 0. We're going to have a condition that checks while I is less than 100, and in the body of the loop, we'll keep incrementing I. And then we'll jump out of the loop as long as this condition is no longer satisfied. So let's start with an example. Let's start with a do-while example. The way do-whiles work is you have, here's an example. We say do, and then the loop body, and then we check a condition. So the first iteration of the loop is always executed no matter what, because we're going to execute at least once before we evaluate the condition. If the condition is true, we're just going to jump back to the beginning of the loop. Now we can look this in the form of goTos, and it's pretty simple, right? We have a label at the beginning of the loop. We're going to execute the body of the loop, evaluate the loop condition. If it's true, we jump back to the beginning of the loop. And then if it's no longer true, this goTo loop is not going to happen. So then we're going to get out of the loop. Okay? So note that we have what we call backwards branching backwards to continue the loop. And only take this backward branch while the condition holds. So let's see how we compile this example. Here we have our loop using the goTo version. Okay? And here's our assembly version on the right. This is just setting EAX to 1 and loading X into EDX. And this .L11 here is just a label for the beginning of the loop. Here we're executing the multiply instruction for this multiply here. We're decrementing X with this instruction. And now we're comparing whether EDX, how it compares to 1. Okay? So now if this comparison says that EDX is greater than 1, we're going to execute the loop. We're going to jump to .L11, which jumps back here. Otherwise, we're going to jump out of the loop. Okay? That's pretty simple, right? So here's how to think about do-while transformations in general. Here's the C code. We go to the goTo version. We're going to have a label at the beginning, and we're going to have an if that checks whether the test for the loop holds, and if it holds, we jump back to the beginning of the loop. Pretty simple, right? So let's see how while loops work now. They're slightly different, right? Note that now we have while at the top. This is no longer a do-while loop. It's a while loop, which means that even for the first iteration, we have to check whether it needs to be executed or not. Okay? So what this is doing, while X is greater than 1, we're going to execute the body of the loop here. And now the biggest difference here is this that you might have noticed is this goTo middle here. What is middle doing? Well, middle is the middle of the loop, and that's where the condition to jump back to the beginning of the loop is evaluated. Okay? So we jump to the middle before executing the first iteration, precisely because we need to evaluate it to see whether even the first iteration needs to be executed. And if so, it jumps to loop and it keeps going. Okay? So the way to think about this, the first iteration jumps over the loop body because we don't want to execute it unless the expression holds. The expression for the loop evaluates to true. So let's look at an example here in assembly. Okay? So similarly to the do while, we have the do while example, we have a multiplication that's implementing this multiplication here, the decrement here, which is it's decrementing x. Now here, this is where the comparison happens. We're comparing edx with 1, and if it's greater than, we jump back to the beginning of the loop. Okay? The main difference here is that now we have a jump to where the condition is, right here, where the condition check is. Right, so that's how we implement while loops, just jumping over the body of the loop compared to do while. Now let's see how we implement a for loop. A for loop essentially has bounds in the number of iterations of the loop. And in this example here, we are doing we're implementing a function that that takes x and p as parameters and computes x raised to the p power. It computes this value here, x raised to p. Okay? So there's a clever algorithm here that exploits a bit representation of p that encourages you to stop and take a look. It's really great, and it's pretty clever. And the way it works is it takes as many steps as the number of bits in p, the numbers of bits necessary to represent p. Okay? And then for every bit of p that's set to 1, we go to the multiplication, it's going to be doing again, and that's why it's called the square multiply. I don't want to get into the details on how exactly it works and why it works, but I encourage you to stop, take a look at the slides, and think about it. Okay? Here's how we can think about our for example that I just showed you. Okay? So here's the code that I had just showed you, and here is a general form of for loops. And a general form looks as follows. There's an init expression that's executed in the beginning of before the loop starts. Okay, so that's what we have here. And the test expression is the expression that determines whether the loop keeps going or not. And that's what. So in our example here, it's whether p is not equal to 0. And then there's the update part that happens at the end of the loop. Okay, so in our example, it's p equals p shifted right by 1. That's the update portion of our for loop. And then, obviously this is the body of the loop. And one way to make you understand how for loops are translated is to translate them to while loops. Okay? So here's a general form that I just showed you. You can think about in a while version of that loop by executing the init expression at the beginning of the loop. We have a while loop that executes while the test expression holds. We execute the body of the loop, okay? And then at the end, right after the body, we execute the update for what we call the induction variable. And then when we go from a while, we can again do the go-to version that we had before, okay? So, and note that the main difference here is that now we have init here and we have updates. That's the main difference between a for and a while loop. So let's see how we apply this to the example that I just showed you in the previous slide. Okay. So here's the general version of the loop and the go-to version. Here's the code of our example. And note that the init here now appears in the beginning, even before you evaluate the expression whether the loop keeps going or not. Right? So now we have go-to middle here, the same thing we had in while. That's where we're going to jump to evaluate whether the condition holds. Okay. And then if the condition holds, we jump to the beginning of the loop to execute the body, which is what we have here. Okay? And now there's one extra step. So we have the init here, the update. The update for the induction variable now happens at the end of the body of the loop, right there. So it looks very similar to a while loop. See you next time.